But, so meanwhile, I'm going to do some extra credit conversation here, okay? So, how many of you have significant experience in another language that is object-oriented? Okay. So I'm going to tell you a little story. This is, so I don't know how many of you know, but I wrote a book called Fluent Python. And the book has been a success. People love it. It's been selling well. It has been translated to 8 languages. But Fluent Python is not a book for people that are learning Python. It's actually, Fluent Python grew out of a course that I used to teach in Brazil, where I live, that was called Python for People Who Know Python. So the idea is, you are already using Python. Python is very easy to get started. And so that course was about making the most of Python and trying to code in idiomatic Python. Because as somebody said, I forgot, somebody famous in the history of computer science once said that it's possible to write Fortran in any programming language, right? And I have seen, because Java is one of the most popular languages, and in the domain that Python is used, Java is also very popular. So I've seen a lot of Python code that had a very strong Java accent, just like my English with a very strong Portuguese accent. So I've seen that in the in Python code. And anyway, because I started writing the book in 2013 and finished in 2015, and then I went to work for ThoughtWorks, where I'm doing other stuff besides coding in Python. I'm also coding in other languages and doing non-coding tasks. This all means that it's been about 8 or 9 years since I've taught an introductory class about object-oriented programming in Python. Fluent Python has chapters about object-oriented programming, but they assume that you already know the basics of object-oriented programming in Python. And this was really interesting for me to, after all these years, start thinking about what should I teach, what should I show to people that are getting started with Python in terms of object-oriented programming. And I went through old slides and exercises from courses that I used to give like 10 years ago or something. And a lot of this stuff was wrong. Because over these years I've learned more about object-oriented programming, for example. And there's been trends also. I'm going to talk about that more, but there's a huge trend away from inheritance. Object-oriented programming was always, when you took an introductory course about object-oriented programming, a lot of time was always spent with inheritance, right? And you had all of those crazy examples of, animals, so you have the animal class and then the mammal class, the mammal subclass, and then the dog subclass of mammal, and the cat and the bat, whatever, right? This is just wrong, people. This is not the way to program classes anymore. So for one thing, in reality, we don't use the inheritance hierarchy to do classification like an animal taxonomy. We don't use it for that. And so I'm going to talk about that. And another thing that, and then also, for instance, there's the famous design patterns book the one that's nicknamed the Book of the Gang of Four, because it has 4 authors, right? So in that book, the introduction of that book is excellent. I think it's actually worth the price of the book, and the rest is not so important, in my opinion. But the introduction is awesome. And then in the introduction, the authors say that you should favor composition over inheritance. I'm going to talk about that and show examples. But this is a famous like proverb that has been written in, I don't know, it was written in 93 or 94, that book. And it's gaining more and more traction. And now we see programming languages emerging. For instance, in the data science space, there is a language called Julia, which is actually why Jupyter starts with GU, because the Jupyter project supports Julia, Python, and R natively. So Julia is a programming language that has inheritance, but only of abstract classes. I'm going to talk about that too. Concrete classes you cannot inherit. Go is another language that is growing very fast. It has a concept of types. They don't call it classes, but they have types with methods, which is very similar to a class. And they have the concept of interfaces, but there is no inheritance at all in Go. So these are some of the things that I basically had to rethink a lot of it. I created lots of examples just for this tutorial. And this is unlike any other course that I've given about this subject, because of the things that happened during these past few years in that area. What else can I say as yeah. Also, before this talk, or before this tutorial, whenever I talked about Pythonic objects, I gave a lot of emphasis in the special methods. I'm going to talk a little bit about them here, but not as much as I talk. My whole book is about 700 pages of special methods, okay? That's the core of the book, because the special methods are the way Python presents itself to the programmer as a toolkit for building frameworks, which is really interesting, but it's not something that you should be concerned when you're just getting started with object-oriented programming in Python. I am going to show one example at the very end that has lots of special methods, but most of them are going to use only a few of the most essential special methods. So just one more minute, and then it's 9:10, and we're going to get started. So for those who arrived after I showed this, that URL is the URL of the repo where the content of the talk is. And I decided not to do slides this time. There's only this opening, sort of like a title card, and everything else is Jupyter notebooks and also examples in code as Python modules. Everything is in this repo. All right. So you can clone the repo, or you can just browse it through the GitHub UI. All right, let's get started. So from now on, it's going to be recording. So good morning, people. Thank you very much for choosing this tutorial. I'm super happy to be here presenting a tutorial at PyCon. This is a conference that I love. I would like for you to not be shy and ask questions whenever you want. Just raise your hand. If I don't notice you, then you can start yelling. And there's a mic that we need to use when people ask questions so that the question is recorded as well, okay? But please don't be shy, all right? So my name is Luciano Ramalho, and I work for ThoughtWorks, and we are going to talk about Pythonic objects, which is essentials of object-oriented programming in Python. We're going to talk a lot about idioms and specifics of Python, okay? So here's the thing. One thing that always bothered me when teaching object-oriented programming with Python, by the way, I love Python, okay? And I think it's a very deeply object-oriented language. In some respects, it's more object-oriented language than Java, for example. Because, for instance, in Python, we don't have primitive objects. We don't have primitive values like the numbers in Java. Everything is an object in Python in the sense that everything was an object in Smalltalk, okay? But there is one particular topic, which is kind of an essential topic of object-oriented programming, that has always been a problem for me to talk about when I talk about Python, and that's because of this. I'm going to show you this screen here is from the book Smalltalk IDE, the language. And that book has, so the language Smalltalk grew together with an entire system, which was an operating system and a graphical user interface and what we call today an IDE. So this is one of the windows where you programmed it. So you see here are the class categories, and then it's the selected category is new project, and then you see financial history, which is the name of the class that's just been created here, that was just created, actually. The previous screenshot in the book showed the person clicking accept to this definition. So the person typed, the user typed this definition, and then when she chose accept, it appeared here as one of the classes. And then it says here no messages, which means that no methods have been defined for it. But if you look at the class definition, it says object subclass financial history. So object subclass means this is a subclass of object, right? In Python 3, we don't need to say that anymore. If you declare a class, it's already a subclass of object, right? If you don't specify a specific superclass, it's going to be a subclass of object. But okay, so this is what this definition says, the name of the new class and where it belongs in the hierarchy, okay? And then you see here, instance variable names. And then there is a string of names separated by spaces, which are, so financial history. I'm actually going to show a Python version of this class later on. But here we have cash on hand, incomes, and expenditures are the instance variable names, okay? So right at the start in Smalltalk, you tell the system the names of the attributes of the class, right? And let's take a look at another important reference, the official Java tutorial, okay? The Java tutorial has these pictures. They talk about what is an object, and they say, so an object is fields in here, and it's surrounded by methods. The idea being that other objects can only communicate with this object through the methods and not have access to the fields directly. In Smalltalk, it was like that too. In fact, in Smalltalk, all the instance variables were private. There was no way to do a public instance variable in Smalltalk. Okay? So it was very much like this. And this is an example of what they call encapsulation, right? So the object encapsulates some values here, which are the fields. Okay. And here's a definition that talks about that. Hiding internal state and requiring all interaction to be performed through an object's methods is known as data encapsulation, a fundamental principle of object-oriented programming, right? So here's an example. I like the example in the picture, although the code is not so good, but the picture, the idea is, so this represents a bicycle. So you have methods that are like verbs of actions that you can do with the bike, so like change gears, brake, change cadence. And then you have the values inside the fields. So this would be the speed because it says 18 miles per hour. This would be the cadence because it says 90 rotations per 90 RPM. And this is the gear, the currently engaged gear, fifth gear, okay? Now, a crucial idea here is that there is no way to change the speed directly. There is no method called change speed. Because the speed of the bicycle is one of the fields in there. It depends on other things, right? So, for instance, if you apply the brake, this will decrease the speed, right? How much? Well, it depends on how much you press the brake and also whether it's going uphill or downhill or whether somebody is pedaling still or not, right? So that's the idea. The idea is that this internal state of the object is changed through method calls that are not necessarily just straight setters and getters like we often see in introductory tutorials. You don't cheat, like I said, it doesn't make sense in a realistic simulation to be able to change the speed directly, right? This would be like you are in a car and you pull the how do you call the speedometer, yeah, the little thingy, how do you call the pointer in the speedometer, and that would make your car go faster. Doesn't make any sense, right? So no. The speed is a consequence of other things that are happening, all right? And if you look at the Java code, it's very clear here that the class bicycle has three fields, cadence, speed, and gear. And then there is other method. There are methods, right? So what I'm talking about here is that both Java and Smalltalk, which are very important object-oriented languages, have specific and explicit ways of defining what are the fields of a class, right? And so I think the way in which Python is less like all the other object-oriented programming languages that I know is the fact that Python historically did not have a way of doing that, and now it's growing a way of doing that. I'm going to talk about that through the typing module and data classes. But historically, there was no way of telling Python, okay, this class has these fields, right? Also, Python has, well, all object-oriented languages have slightly varying terminologies, right? But if you know about Java, it's useful to know that the Python term, what we call attributes in Python, is a generic term that encompasses the concepts of fields and methods in Java. Okay, all of that we consider in Python methods, attributes of the object as well, right? And then when you want to talk about what Java people call a field, we need to use this qualifier and call it a data attribute, okay? And then a method is a method, all right? So it's important to understand these different terms that I use. So like I was saying, Python prior to Python 3.6 had no way to declare instance variables without assigning. Actually, the assignment is what creates, the initial assignment is what creates a variable, okay? But it's more than that, because Python historically had no way to declare variables at all, no kinds of variables you had any way of declaring. The only kinds of variables that you declare in Python are function arguments, right? Okay, so the first assignment is the declaration, and the attributes defined in a class body are class attributes. I'm going to talk about that. But then, I don't know how many of you have studied or used Django. All right, lots of people. So I was using Python. I started using Python in '98, and about, I don't know, 2005, 2006, around that time, I started studying Django, and I looked at this, and I said, what's going on here? You know? Because what you see here, I just said that attributes defined in a class body are class attributes. So these attributes here, which are in the body of the class and not inside a function or a method, they are class attributes. But clearly, they are defining something that has to do with the instances, right? So a musician has a first name, a last name, and an instrument. Each musician would have a different name, right? So this is an instance attribute. However, it's defined in the class. How does that work? Well, this is a very advanced topic called descriptors, right? So these objects that are instantiated here are descriptors. And I want to say, I want to talk about that just because I don't want to go deeper into this subject, but I want to make sure that you believe and you understand that everything that is defined in a class body are class attributes. However, a descriptor is a class attribute that is designed to manage attributes in the instances. Does that make sense? You know, think about a getter or a setter. So a getter or a setter is just a method that, a getter is a method that just retrieves the value of a data attribute, right? That's all it does. So a getter is a method, and now in methods, because they are defined in the class, they are basically class attributes. But methods usually handle attributes of the instances. Does that make sense? The descriptor is another category of things that are not methods that have the same characteristic of something that is attached to the class, but that is designed to handle the instances. Okay? But I was surprised when I saw this in Python or in Django, because I was already using the language for several years, like 7 years when I saw this, and I had never seen a descriptor before. And because the fact is, in the Python standard library, there are no data-oriented descriptors like this. All the ones that exist out there are provided by frameworks like Django, SQL Alchemy, and things like that. So it's kind of a foreign idea. Well, of course, the infrastructure is there in the language for people to use it, and the framework authors have used it, but it's an advanced concept, this idea of the descriptor. So let's get back to basics, really basics. And now I'm going to start running code here. So the first thing I always do when I teach with a Jupyter Notebook. So I don't know if everybody knows about Jupyter Notebooks. The idea here is, so I am actually running this from the terminal here. This is the log of the server, right? I run it by typing Jupyter space notebook, but I didn't. I don't think it's important for you to be running this right now. And the thing is, each of these cells, when it doesn't have a number, like this one and this one, it means that they were not executed yet. And this one was just executed. To execute it, I hit shift return. Okay? So I'm going to execute this cell, and now I just defined the class coordinate. Okay, what I had done before was just printing the Python version to make sure everybody understand that we are using Python 3.7, because some of the features I'm going to show depend on 3.7. All right, so I've defined the class. What does this class have? It just has a doc string. In the second line of a class, if you want to declare an empty class, you have to put something in there because of the syntax of Python requires. So you can put the pass keyword, or I prefer to put a doc string. It serves the purpose of filling that space, and it's better than the password keyword because it says something. Okay, so I can create a coordinate, and I can assign a latitude and a longitude to it, and I can then, this last line will make Jupyter show the value. Okay, so this is what we saw. So we have an object. Okay, and this is how it's displayed. I'm going to add another line here, or another cell, just to show you that I can actually look at the latitude of Cleveland. See? So I'm accessing the attributes. So this is the first thing that is very surprising. Not only there is no way to declare, there's no way to declare class or instance attributes or data attributes, but you don't need to, because you can create a class and just assign merely attributes to the instances. Okay? By default, this is how Python classes behave. It's not a good idea to be, hanging new attributes while the class is being passed around the system. I once saw a very ugly bug that was because of that, but you can do it. All right, so in order to teach and also to test and document, I like to implement a method called underwrapper. All right, so this is one thing that I consider an essential characteristic of a Pythonic class. So what's the idea? Since the times of Smalltalk, the people who have created object-oriented programming languages have realized that it's important for objects to have a way to present themselves as a string, right? So if I have if I say print this object, the print function will call something on the object so that the object is responsible for displaying itself. Okay? This is a very object-oriented way of thinking, right? Objects should be responsible for actions that have to do with their internal state, right? So, for instance, if I have to display myself, I have to show some attributes, my name or whatever. This should be my task as an object. But also, so in other languages like Java, you have a toString method. Pretty much every object-oriented language has some method that is designed that you should implement so that your objects can represent themselves as strings. But Python has two methods, dunder. So and we pronounce this dunder wrapper. Okay, so dunder is the double underscore on both sides. Dunder wrapper is one of the methods that you use. And the idea is that dunder wrapper is to show a technical representation of the object. Let's call it that, okay? So a way of showing the object that is useful for debugging or for logging or for teaching. And that's in contrast with a way of displaying a user-friendly string of the object, okay? Which we are going to do soon. But anyway, I don't need this import geohash right now here. This is a leftover from another iteration. And now, see the difference? So because now I have a dunder wrapper, my object doesn't display like that anymore. This is the dunder wrapper that my class inherited from objects. The object class shows objects like this, the name of the class and the position in memory, just as a way of uniquely identifying that instance so that you know whether two instances are the same or different. Okay? Now, if you implement dunder wrapper, then you can make your objects appear some other way. And this is actually a good way of doing that, which is to display the object as the source code that you would use to reconstruct a copy of the object. Does that make sense? See, this is like calling the class and passing two arguments to build the object, right? So some good practice, some best practices about the dunder wrapper. So dunder wrapper is good for exploratory programming, documentation, docs tests, and debugging. The best practice, if viable, it's not always viable, but you should implement dunder wrapper returning a string with syntax required to create a new instance like the one inspected, like I just said, right? This string here, if I copy and paste it in a terminal, in a Python shell, is going to create another coordinate like that one. A more technical way of saying is that the wrapper function, which is a built-in function of Python, calls the dunder wrapper of objects, right? So when you call wrapper of X, you get a string. If you eval that string, you should get an object that will be equal to the original X. Does that make sense? Now I want to explain something that is kind of weird. So we have a method called dunder wrapper, but then let me show you this this thing here. So what happens if I do this? Sorry, I have to call it. I get that string, right? And what happens if I do this? The same string. So, which is better? Of course, this is more readable, although it does cause some concern to people coming from other languages because this doesn't look object-oriented, you know? Most object-oriented languages these days have this kind of syntax where it's always object.method to make the call, right? But in this case, it's like this. And you will see this over and over in Python. You have the len function. You have a bunch of built-in functions that are named like special methods and that you use like this. You should never do this, right? The special methods are not designed for you to be calling them. Python calls them for you when necessary. So what's the sense of that? Why is this like this? Because the thing is, for built-in objects, which are part of the Python interpreter and that are implemented in C, or for things that are not part of the interpreter but are also implemented in C, like for instance, the NumPy objects, the ND array, everything else in data science, most of those objects that you use when you're doing data science in Python, they are implemented in C. Some of them are implemented in other languages, but most of them are implemented in C. For an object implemented in C, Python has a shortcut. So when you call wrapper of an object, Python sees, okay, is this implemented in C? So there's a quicker way of making that happen that doesn't involve all the machinery of calling a method, which has to do with expensive machinery because it has to do with all the dynamic way of looking up methods in the inheritance hierarchy and so on. And so the thing is, that's why you have this syntax, because this syntax is faster for built-in objects and objects implemented in C, but it has a fallback, which is when you apply the wrapper function to an object that you created or somebody created in Python, then the system will fall back to do this, right? So does that make sense? I wanted to explain because sometimes people accuse Python of not being object-oriented because of this syntax. Okay? But it's just like, it's a pragmatic solution to be able to be very fast with the built-ins. Okay? All right. I've already said that, so there's another, I said that there's another representation for end users, and that's done with the dunderstir. And here is a nice dunderstir. I'm going to run it. So I just defined the class again, and then I'm going to explain the code soon. But see, isn't this nice? So now when I print a coordinate, it looks like the way users like to see coordinates. Right? So, all right. Oops. Something is not great here. All right, thank you. So another thing that is a bit surprising when people get started with Python is that a method definition like this when it's an instance method, the method that deals with the instance, and most methods that you're going to create deal with the instance, they have to receive the self argument, which is not part of the call, right? So but the idea is that this is actually has to do with the descriptor mechanism as well. But anyway, this makes, so when Python sees this, it passes this instance as the self argument. And so we have this other thing. Now I have a little shortcut here that I don't know if I am ashamed or proud of it, but I'm going to show you because it's kind of interesting. How does this work? So in order to select whether I'm going to write N or W, or N or S, or W or E in the coordinates, I use this crazy expression here. This actually doesn't look like Python, but it is Python. So let me tell you what's going on here. This expression here returns a Boolean, right? All the comparison operators in Python return Booleans. And a Boolean in Python is actually a subclass of int. The true value is 1, and the zero value, or the false value is 0, okay? So because the Booleans are a type of int, a subtype of int, you can use them in arithmetic, which sometimes is interesting. You can have an equation where there's a certain term that should be 0 if a certain condition applies. So you can use it like that. And in this situation, I'm using it as an index to this string. So if this is false, then I'm going to display, so the result of this is going to be 0. And I'm reading the 0 index of this string, which is the letter n, right? Otherwise, if it's true, then it's going to select the s, okay? And over here is all the cool kids are using f strings. It's really cool. I'm not going to explain it a lot. I'm just going to say that it's pretty powerful because it allows you to put actually expressions. See, I have a function call here. I'm calling the abs of the latitude, and then I have so this part here is an expression, and after the colon is the formatting. All of this inside these braces here, right? And this is just the variable, this variable here, okay? Anyway, so it seems to be working, this class of ours, except that we kind of punted on the whole topic of attributes, which is what I was talking about, right? Because when I created the class to demonstrate, every time I did like this. I created an instance, and then I assigned the attributes. If I don't do that, I get an exception that says object has no attribute lat, okay? The reason why I wrote all of this exception handling here is because otherwise we would see this here. And also, if I tell Jupyter Notebook to run everything to see if everything is okay, it stops here and it doesn't run the remaining cells. So that's why I do this way here, where I catch the exception and I print the message. Okay? Anyway, so what can I do to fix this? So the quick and dirty fix for this is to create two attributes here. So if I run this again, so I just added the attributes there in the body of the class, right? So they are class attributes. But now, when I run this, it works. And this is a peculiar thing about Python. The fact that what is happening implicitly here, for this print to execute, this dunder stir is being called. And the dunder stir accesses self.lat and self.long, right? So it's looking at attributes in the instance. However, the instance doesn't have the attributes. So then Python looks at the class and gets those values. So this way here is a way of having sort of default values for attributes. But I don't think this is very clean, and I actually don't recommend it anymore. I'm going to be talking a lot more about that. Okay? Here's another example of using class attributes as default. So for instance, I have a class called pizza. It doesn't have any methods, just class attributes, class data attributes, to be more precise. So I can create a pizza instance, and I can ask for the slices, and I get that. And I can ask for the flavor, and it's cheese. And here's the thing. The dunder dict is a special attribute that most Python objects have. Some don't have it. but most Python objects have the dunderdict, and the dunderdict is basically a dictionary that tells you what are the attributes of that particular instance. Okay, and as you can see, even though I was asking about the slices and the flavor of the P instance, it doesn't have any attribute because it's getting everything from the class. Now, if I assign and look at the dict, then I see the value appear as an instance attribute. So there's an asymmetry here, which is when you read an attribute that doesn't exist in the instance, it goes looking at the class. But if you assign, it doesn't look at the class. It just assigns to the instance, which means that if I create if I create another pizza here, and ask for the flavor, it's going to be cheese, because that's the default that's in the class, right? The fact that I assigned to the instance didn't change the class at all. So I can check and see the dict of the pizza of the class. The dict of the class, the dict of the class is wrapped into this thing called the mapping proxy. It's just sort of like a read-only dictionary. But as you can see, it has the attributes that are declared explicitly in the class, like diameter, slices, flavor 2, and then it has other things, including this is where the docstring would be, if there was docstring, but I didn't create docstring in this case. All right? So now to wrap up this session here, I'm going to show a better pizza. So this is what I consider gourmet professional pizza, okay? And what I did here is I created those two attributes. I consider them class attributes, okay? Because every pizza that I make are going to be 40 centimeters in diameter and 8 slices. Okay? They are sort of like a configuration option of the class. And the class is a factory of objects, right? So I can configure the class so that it starts making instances with those characteristics. So these are class attributes. And the instance attributes, the proper way of doing them today is to assign them all inside the dunder init. So dunder init, some people call it the constructor, because it does what the constructor does in Java, but it's actually not a constructor because it gets the object as the first argument. See, so the object has already been constructed. What the dunder init does is it initializes. That's why it's called dunder init, right? So it gets the instance, and then you initialize whatever you need to initialize here. And this is the most official way, traditionally, of declaring instance attributes in Python, is assigning them in the dunder init. And it's a best practice. You should always assign everything that is going to be in all instances in the dunder init, and not do it piecemeal in different methods and so on, or later. No. If you want to create an attribute later, the best practice is to create it in the dunder init and assign none to it, okay? Or some empty value, like an empty list or whatever. And then later, when you have data to put in, the important thing is that the attribute is already declared so that people reading your class will know what to expect. So this class, so here we're dealing with the deficiency in Python. Get it? The deficiency is there is no explicit way of telling Python what are the instance attributes. So the best we can do is adopt conventions, and this is the best convention we have. Assign them all in the under init. All right? So, the good practices shown here are that I use class attributes for attributes that are shared among all the instances. And the attributes that are expected to vary among instances are instance attributes, and the instance attributes were all assigned in the under init. And the default value for instance attributes are argument defaults in the under init, right? So I can create a pizza without specifying the flavors because it has the under init has default arguments, right? So this is the best practice. And actually, besides readability, which is a very important thing to have in a system, because systems source code is read much more often than it is written. So it's important for source code to be readable. But there is now, for people who are more motivated by performance, there is a technical reason to do that. There was a PEP, and it's not so new actually. It came out around Python 3.4. So PEP 412 documents an optimization which is designed for this situation here. Let's suppose I have Amazon pizza. So I have 1 million pizzas in the queue. And that means that I will have 1 million dictionaries with the attributes of, each pizza has its own dictionary with the attributes, right? The under dict. What this PEP does is they created this optimization where Python notices when you create an instance that the keys of this instance dict are the same keys of another instance's dict, and they share, and Python shares the keys, which is basically a hash, the name, and a hash and the value of the key, which may be a long string or an arbitrary object. So this key sharing can lead to significant economy of memory. But it only happens if you follow strictly this practice of initializing all your instances with all the instances attributes at once. Anytime you, after the fact, decide to add another attribute, then this forces Python to remove that dictionary and copy it to another place where it's going to be a singleton and not be sharing keys with others, right? So, all right. So I would like to propose that you do a little bit of coding. And the idea is there is actually in the Google, oh, sorry, I forgot something. I need to hand out something. Let me get it here. Yeah, okay. So, oops, wrong. Okay, wrong link. There's no, yeah, I simplified the link, but I forgot to add it there. I'm gonna add it there. So this is the link, and I'm gonna fix the notebook, sorry. Later, I decided to simplify. Oh, actually, what did I do here? Wait, I think it's, I know what I did. I changed the label, but I didn't change the actual link. All right, so now it works, and I'm gonna commit and push so that you have this fixed version. All right, so I suggest that you do it in pairs. And what I want to propose, so the exercise is described in this document here. All right? So there's 3 steps, but let's call the 3rd step a bonus, okay? Do it only if you have time. And what I'm going to do is I'm going to hand out Post-its. And if you want to do the exercise, I'm going to ask you to do this. If you have an issue, if you need help, you're going to stick a red Post-it to your screen here. And when you're done with the step 2, okay, because 3 is a bonus. If you're done with step 2, you stick the green one. So when there's a bunch of people with the green one, we need to move on, all right? That's the idea. So please pass them around. So take one of each color. And what I'm going to, so the basic instructions I'm going to show what's happening here is that we have, sorry? Oh, yeah? Oh, okay. The fix needs a fix. Okay, sorry. Oh, it says 1 here.
Yeah, the link is.
Yeah, I'm going to show you how to get there. So if you go to the repo, it's so PyOB, the link, and then labs, and then 1, and then this is it, right? So for instance, if I use this command here, so this is another feature of Python that is not very well known, which is the doc test. I'm going to show you how it works. So if I go there to the labs 1, okay, this is what I have, and I type this command, and what happened is this. Okay, so what is going on here? I'm running the doc test module, which comes with Python. So this is what the -m doc test does on the readme.rst file, which is a text file. And the -f at the end is just so that it stops at the first failure, because otherwise it's going to show a lot of other things that are wrong, that are what the exercise is about. The exercise is about fixing those things. But anyway, if you do -f, you're going to do step by step, okay? So it stops at the first. And what does it say? It's failed example, goof of Guinea. Coordinate object has no attribute lat. Okay, so the problem is that it's asking you to create an init accepting a latitude and a longitude, right? And the class that you have there doesn't have that. So I'm going to cheat and just say, and this is not what the exercise is intended to do, but just to show you the doc test running. If I create the lat attribute like I had done over there, and I run it again, whoops. Now it's going to complain about the lack of the long. and so on, right? So actually, the doc tests, if you run it like this with -f, they're going to guide you through what you need to do. But if you start by doing the first step, which is to create the dunder init, like I had shown before, you can pass. So this is the example that is actually running. So what doctest does is it looks at text that has prompts that look like the Python prompt, executes the code and see if and checks whether the output is the same as appears here. This is what doctest does. The idea of doctest is to make sure that the examples in documentation are accurate. But I also like to use them as a scaffolding for exercises like we're using now. So the first step is actually like the code that I just showed you with the init. The second step is new. The idea is that you're going to create a class attribute. The example shows that you can access the class attribute through the class coordinate or through an instance. And step 3 is where you implement an encode the geohash method here. And here's what's gonna happen. I was supposed to read these announcements to you because we have a break. So we're gonna have a break at 10:15, okay? And it says snacks go quickly, so please let your group out at the right time. Right? So actually, if you wanna step outside soon, go ahead, and then we can come back. I don't know what's the length of the break, the duration of the break. Let me try and find out. Well, let's do a 15-minute break, okay? So the idea is we'll come back. You can step outside whenever you like, and we'll come back at 10:30, okay? Or you can come back earlier and finish the exercise or whatever. Lunch will be at 12:20. And then it says here, we have placed as much power as we could afford. Please share the outlets. And there's a survey link to the tutorial. I don't know if you have that. Have you gotten a piece of paper that has this link? Otherwise, I'm going to put it in the presentation here. It's a SurveyMonkey link with a bunch of letters. I'm going to put it in the last presentation. The last. Yes, all right. So I put the link in the last page that we're gonna see. So I'm gonna step outside and come back in 15 minutes, okay? And then we resume. Let's go eat before it's all over.
Get all tangled up in there.
let's get going. So maybe you noticed that there was a spoiler because the solution was right at the page that we were looking at, right? So, and the geohash is a very interesting thing because it computes an alphanumerical hash that has some very interesting properties. Oh, that's in the README actually. The property is that, you see, I have here the coordinates of the airport of Cleveland, the one on the west, and this is the coordinate of the city, as it appears, I think, on Wikipedia. And you see that the first three letters are the same. So this is what is cool about geohashes, is that it's super fast to compare. It's very easy to determine whether two things are close, depending on the number of letters that match. And if you have more letters matching, that means it's really close. If you have like 10 letters matching, that's probably in the next room, right? Of course, there are exceptions because it involves cutting the word in squares, and if you are on a boundary, then you have to check other things. But at most, you do 8 different checks, and you can determine whether something is very close or not. Anyway, geohash is cool. All right, so what I'm gonna do is, so the next topic is actually something that is, these are, the first examples that we just saw are new for this tutorial. The examples here are from my book, and I'm kind of, I want to, there's more interesting stuff to see rather than these examples. What I'm going to talk about, so I'm going to just speed through this page and then we're going to go to the next one. But this page is something that you can study later if my super quick explanation here leaves you with questions, or you can ask me later too. But these are all, the Haunted Bus and the Haunted Bus version 2 and the Twilight Bus, they are bad for you, okay? The good bus is the bus, all right? So this is basically 3 counterexamples that talk about problems that can happen when you have like a default argument, default class attribute that is mutable, and you're using it as the default for the instances. So what happens with the Haunted Bus is basically you create this bus 1 instance and you put 2 people in it. And then when you create the bus 2 version, the bus 2 instance, you have the ghosts of the same people. So they are in both buses. This is really scary. And the other example is you don't have a class attribute anymore, but you have a mutable default in the constructor, and that basically has the same issue. Because think about it. Like I said before, methods are class attributes, right? And default values in method declarations are attributes of the methods. So this empty list is an attribute of dunderInit, and dunderInit is a method of the class. So indirectly, this is an attribute of the class as well. So you have the exact same issue. This last example is more subtle. Oh, sorry. Actually, this is fixed. This is not what I wanted it to be. Yeah, sorry. I was trying it out later, sooner, and it's wrong. Okay, so this is correct, and I'm going to save it soon. This is what it was intended to be. Okay, then the idea is for this example, this looks pretty good, okay? Because you don't have a default in the class, and you follow this idiom of, for any mutable argument, you put none as the default, and then you check, and you explicitly create an empty list in this case, okay? So this looks okay, but there is a subtle problem with it. So we have a hockey team here with 6 women, all right? And then I am loading the bus, the toilet bus, with the 6 players, passengers. So what happened is passenger is not none in this case, it's the hockey team. So I have this assignment here. And now the bus, which is bus 5, is going to drop Sue and Pat. And you can see that they're no longer in the bus. Yes, but they are no longer in the hockey team either. So they fell into a void, right? And you know, a lot of Python programmers will look at this code and say that it's okay, but there is this subtle problem. And the solution to the problem is, this assignment here is dangerous because you're using this as a list. You can see that it's a list because I'm calling append and remove methods. And also in the default case, I'm creating an empty list. But if I just assign the argument, my instance is actually sharing the list that was passed. And as I drop people along the way, I'm actually removing them from the list that I got. And this is probably not what the end user wants. So there's 2 ways to fix this. One way is using this notation, which creates a copy of the list. But if you get a tuple argument, the dunder init will work, but will create a copy of the tuple. But then the class will break later because you're going to try and do append and remove in the tuple, and it doesn't work. So the best way is to do this. So what I'm doing here is actually I'm using the passengers list as the argument to the constructor of a new list. So this does create a copy, but it's more flexible than the other notation because if I get a tuple, if I get a tuple as an argument, I'm building a list from it. If I get any iterable as argument, I'm building a list of it, right? So it's flexible and safe at the same time. And this is the best solution. So now if we run the test, you see that the hockey team is still complete. All right? So this is a best practice to take whatever arguments that you get that are mutable and make a copy. Of course, there are exceptions, right? Maybe it's 10 million items in this list and you don't want to copy 10 million items, but then you have to document, pay attention, I'm going to change whatever you pass me, But by default, I think this is a very good practice. And it also is also, so, and this is the solution of the bus. Yeah, all right. Okay. And it's also an example, if I do, like I said, as I convert the argument to a list, I am offering flexibility to the user. They can pass any iterable object, and I will build a list from it. And this is an example of Postel's law, which is one of a best practice in the internet. Right? Be conservative in what you send and be liberal in what you accept. In fact, if people did that on Facebook or Twitter, that would be awesome too, right? Anyway, so let's now. So I started talking about how Python doesn't have an easy way of declaring class attributes, and this is particularly painful with classes like this one that I'm back to the page 1 here. So this class is basically, a pair of coordinates, right? There's not a whole lot of functionality. The most interesting functionality here is the geohash method that we added later. But it's basically just like a struct or a record in a database. It has two numbers, and that's it, right? So the fact that Python didn't have an easy way to declare the instance attributes made it difficult to avoid this kind of boilerplate of having to write this dunder init with a lot of repetition of the names of the arguments assigning to the and then dunder wrapper, which is like a standard thing that looks like this. And so there's a lot of boilerplate involved here. So over the years, and this is our next subject, the Python community has evolved ways of dealing with these kinds of classes, which are called data classes. And here I'm using a space, okay? Because I'm using the term in like a general term. What is a data class? A data class is mostly just like a struct. It's a class that looks like a database record. It doesn't have a lot of algorithms. It doesn't have a lot of weird methods. It just stores fields and displays fields and lets you access the fields, okay? So other languages have grown this kind of features too. Ruby has always had a very simple way of doing this. And the first solution to this problem that appeared was named tuple. Named tuple is pretty old. I don't know when it started, but probably more than 10 years old. But anyway, so named tuple is actually a function that you call passing two arguments. The first is the name of a class so named tuple is a factory of classes, okay? And by the way, this is one way in which Python is more object-oriented than Java. Because in Java, the classes are not full first-class classes or objects. What I mean is, in Java, you cannot write Java code, just pure Java code, to create a class at runtime. If you need to create a class at runtime, you need to write bytecode. You need to generate bytecode at runtime. But in Python, classes are objects. And as such, they can be created at runtime. And this is a function that creates, when I invoke this, it creates a class with this name and with these attributes. Okay? And now I use it like this. And you see it has a very nice dunder wrapper by default that spells out the name of the arguments. And it's any class created by named tuple is actually a subtype of tuple. So that means I can use this notation here to unpack the values. See? This object is an instance of my class, and it also behaves like a tuple. I can do this multiple assignments, and I can read the different parts, all right? And it includes a dunder eq method. The dunder eq method is the one that implements the equality operator, right? And the dunder eq that is generated by the named tuple factory actually knows how to compare my instances with any tuple. See? So named tuple is pretty cool. I use it a lot. But there are some limitations. Limitations are not always bad, right? Sometimes it's good to have limitations because you're being explicit. I don't need anything fancier than a named tuple here. I'm going to use a named tuple. Named tuples are also they use less memory than classes because they don't have a dunder dict. They have another mechanism called dunder slots, which is less flexible but saves memory. The problem is the instances are immutable. This may be a problem or not. It's a limitation. Maybe it's a feature, depending on your situation. And there's no simple way to implement custom methods. So for instance, if I wanted to put our custom dunder stir or the geohash method that we created before, there's no simple way to do that because I just can't edit. I don't see the body of the class anywhere in my source code, right? So You could do it through monkey patching, but that's not the case. Anyway, so then something interesting happened. So Python is now doing this whole movement towards a system of typing that allows you to declare the types of variables and function arguments and function return types and so on. And in Python 3.5, they invented this thing called named tuple, typing named tuple, which is very similar to the traditional named tuple, except that when you specify the named tuple with the typing named tuple class, in that case is a class, you can specify the types. And there's actually two syntaxes, but this is the more interesting syntax that appeared in Python 3.6. So in Python 3.5, the typing named tuple had a syntax that is similar to the old named tuple. And in Python 3.6, they added syntax for variable declarations, and that allowed this kind of notation. Okay? So basically, this does everything that except it doesn't have this has a nice wrapper. It has equality. It has a lot of features. And I can also add methods. But there is a trick, because remember when I said that for all of the history of Python until Python 3.6, anything that was declared at the class level was a class attribute, but not anymore. Whenever you have a type, a notation near a variable name at the class level, this is interpreted by Python as an instance attribute. Okay? So now that thing that was missing for many years in Python, we have it. But unfortunately, in my opinion as a teacher, it's a bit confusing, the scenario. Because some things that you always thought was true, like anything declared at the class body is a class attribute, is no longer true. And in fact, notice the situation here. This is a class attribute. You know why? Because there is no type declaration. So that's really subtle, right? I don't like that too much. I like the features, but I don't like to explain it, which probably means there's something wrong with it, right? Yeah, okay. So the other day, so I'm starting to dive deeply into the whole typing infrastructure, because that was something that appeared after I wrote my book, and I'm working on the second edition. And this whole subject is very complicated, and it's probably going to take 3 chapters in the new edition to explain. And that's not going to be super detailed, just to give an overview. But one thing that is true about it that I tweeted the other day is the good thing about typing in Python is that it's optional. Actually, the best thing about typing in Python is that it's optional. And this is not just a joke. It means that you can add it when you feel like it, but when you don't feel like it, just use an old named tuple or don't declare the types anywhere. This is so you can ease into it by using it step by step. It's sort of like TypeScript and also the Dart language from Google. Those are examples of languages that have this characteristic of optional typing. Okay. Anyway, oops, what is happening here? Oh, okay, I need to run this because I need I ran this, and now I'm going to run this, and it works. And then the nice thing. Oh, here's an interesting thing. Now I'm going to try and do an assignment. And look at what happens. I get an error because it's a tuple, remember? and tuples are immutable. So once I created this coordinate, I can't assign to its attributes anymore. And I cannot assign, interestingly enough, I can read the reference system, which is the class variable there, the class attribute, but I cannot assign to it either. See? All right, so this is another option that we have now to create these kinds of data classes. And now let's talk about the properly named data class. So data class is a brand new thing, and it comes as a decorator, right? Yet another example of how inheritance is going out of fashion, because they chose to implement this as a decorator and not, like in this case here, through inheritance. See? And anyway, so what is a class decorator? A class decorator is actually a function that when the Python interpreter reads this class the first time, when it defines this class, what happens when you execute a class statement? Everything in the body of the class is defined, and this whole bundle of things becomes a class object, right? This object, which is a class. And this whole object is passed to the data class decorator, which can then do stuff with it. And what the data class decorator mostly does is it creates methods for you so that the boilerplate is gone, right? Like the Dunder wrapper and others. Now there's a different kind of syntax here. I could have written this like this, like in the example of the named tuple. So this is a class attribute. But if you want to specify the type of a class attribute, and in this case, it's more important because it's mutable. It can be updated, right? So in the other case, it's not supported. I don't know why, but it's not super important because in a named tuple, this cannot be changed. So by reading the source code, you know what the type of this is, right? Because it's a string here, and it will never change. But in this case, because by default, data classes are mutable, what if I want to specify the type? Then you have to use this notation here. And so you need to import from class var, and then you say class var, and then within the square brackets, you say what the type is. So this is the way of, so again, it becomes tricky, right, the syntax, because this is a class attribute. This is an instance attribute. But this is a class attribute. Right? It's becoming a bit complicated. Now, does this mean that with those type declarations, even in the case of the named tuple as well, does this mean that Python will do type checking for you? It does not. And this is kind of weird. But the whole point of these annotations is to support IDEs, like PyCharm and others, and to support tools that linters that you can use in the command line like MyPy. Okay? So I can actually show an example here that I have, which is, in order to show this example, I cannot use the Jupyter Notebook because I want to use MyPy to show you. So in examples here, I have coordinates. See, I'm gonna do so these are the coordinates of São Paulo, the city where I live, more or less. Okay, and I'm gonna run this. See, and it shows the coordinates. Now, but if I write here blah, well, what happened was a type error because of some operation that I did, right? So there was no type check. You had a runtime check. But if I run MyPy, so MyPy knows to read that. So in addition to the kinds of tools that we use to check the correctness of the code and other linters, if you use MyPy in your tool chain, it will catch these errors without running your program. That's the idea of the annotations. Okay, so the data class decorator, I used it in the simplest way, but it's actually a function that you can pass a lot of arguments to it. And I have this little table here that summarizes what the arguments are. So the first, most of them have to do with whether or not the decorator will generate methods for your class. Okay? So by default, it generates a dunder init, a dunder wrapper, and a dunder EQ. If you want to be able to sort, for instance, collections of this type that you're creating, you need to also pass this order, which by default is false, but if you set it to true, then it will generate other methods that allow you to compare whether a certain thing is greater than another, or smaller or equal than another, things like that. The hash, I won't be able to comment. It's complicated, and I put it here. It has complex semantics and several caveats, but the idea is has to do with implementing the under hash is one of the things that you need to do to enable to allow your objects to be hashable, and when they are hashable, they can be put in sets, and they can be used as keys in dictionaries. But this is a complicated topic that we don't have time to cover here. And you can also say that it's frozen. By default, it says false, but you can say frozen equals true, right? The asterisk in the beginning of the declaration here means that if you're going to use any of these arguments, you need to prefix it with the name of the keyword. Okay, so it doesn't matter the order. You have to spell out all the names of the options. So if you want something that behaves like a tuple in the sense that it's not mutable, you say frozen equals true. All right. Okay, just to show another example of a data class that's more complicated, this is a data class that represents a Dublin Core resource. So Dublin Core is a standard in information sciences for describing media in general, books, films, recordings, pictures, whatever, paintings. And this here, I just instantiated the card, the class, and I'm gonna put the data about my book. So I'm creating a resource with all of these values, right? And then I'm gonna, and if I ask to show it, it shows a nice wrapper that is broken into several lines, but this would work as source code, right? Because when Python sees an opening parenthesis, until that parenthesis closes, all the line breaks are ignored. They become like spaces. The same thing happens with braces and square brackets, right? So this actually is valid syntax. And but I'm going to show you, because this has two fields that are lists. The creator field, it's called creators, is a list of strings. See? But I want to have a default value, because I want to be able to create a resource like this, and then later fill it up. So I have the default list, but I don't have to have I don't want to have a haunted resource that has ghost values floating around. So how do you do that? Is by using this field function that comes from the data classes module. So the field function, the most common use of it is this one, which is to to give a function that's going to be called by the data class to create the default value of every new instance that's created when the default value is required, right? So that the list is not shared among the instances, okay? And in the wrapper here, which I created because I wanted to be able to display a nice, wrapper with one argument per line here. So I hand-rolled this done the wrapper, and you can see that I'm using the fields function, which is also from the data classes module. And what that does is it lists the fields of the class for you, right? So here I iterate over the fields. So in the end, remember when I said at first that in Python terms, we call what the Java people call fields, we call data attributes? Okay, that's true. But in the specific domain of data classes, the things that are named with types are fields. So a field is a specific type of, or a specific kind of data attribute which has a type annotation. Okay. And the field function also takes a lot of arguments. If you look at so Jupyter Notebook has this shortcut like IPython does. You put a question mark and it shows the help of the thing. So see, it has a bunch of attributes or arguments that I don't have time to explain. But the most important one by far is the default factor. The init, which by default is true, means that this field will be an argument for the initializer, for dunder init, and it's going to be assigned in the dunder init. Maybe you have a field that you don't want to be an argument for the dunder init, then you set this init to false, and so on. The compare, for instance, by default is true, but if it's false, means that specific field will not be used as a criteria for comparison of two instances. So this is a super quick overview of different ways of doing data classes in Python. So we have the traditional named tuple, and now we have the more modern typing named tuple, which allows you to create methods but requires you to do type annotations, and data classes, which are more flexible. Okay? So, all right. Now, let's talk about classes. So one of the issues with the examples that we've seen so far is that they're very data-driven, and also they're like standalone classes. And I wanted to show examples of classes interacting. In this example here, I'm using UML to describe what we are going to have. Let me show what it does first. So actually, I'm going to skip a little bit, and then we're going to come back. So the idea of this example is I have this budget class. Okay. Whoops. I have this budget class, which it's for people. When I used to go out camping a lot, and when we went camping, a bunch of people. Some people had to buy stuff before we went on the trip, and people bought stuff with spent different amounts of money. So the idea of this is you start a budget by giving the names of the people that are going to be on the trip, and then initially the total is 0. There's a method called people that lists the people that are on the trip, and then there's a method called contribute that you call with the name of somebody that is on the trip, and the amount that they've spent. And then when you ask for the total, it gives you the total amount that everybody has spent is 100 here. And the most interesting part is the report. Because the report, if you run the report method, it's going to tell you what was the total, what is the individual share. And then it says Charlie paid 0, his balance is 25. Minus 25. Anne paid 10, her balance is minus 15. Debbie paid 40, her balance is 15, so she needs to get 15. And Bob paid 50, he needs to get 25. Okay? So that settles all the expenses. All right, so this is what this class does, but it has the solution that I created has 2 classes. A budget has several campers, right? And in UML, you have these boxes here that represent a class, the name of the class. These are attributes. The underlined ones are class attributes, and the without underline are instance attributes. And the box below is the methods. Again, there are methods here. Budget apparently does not have instance attribute, but it actually has, because this notation here means that budget has an attribute called underscore campers, which has a bunch of these instances. Okay? So we don't duplicate this name in there. But anyway, so this is the description, and now we are going to take a look at and what does a camper do? So a camper, you create a camper with a name, and then you invoke the pay method, so that adds to the amount that person has paid. And then there's a function called display, which is a little bit complicated because I want to be able to create this tabulation at the end. See where the columns are aligned here. So the logic to do the columns alignment is in the display method here. So if I just display one person, it's like that. But if I use display in a loop like this, I have the columns aligned. And I'm going to show you how that's done. Okay, so this example is in the repository right here. camping. So it's PyOB, examples, camping. And I created 3 solutions, but I won't have time to show the one class solution. The one class solution is just what it says. It has just one class budget. The 2 class solution is the one that I'm talking about. It has the camper and the budget classes. Okay, so the camper has 2 class attributes. One is just a template that is used by the display method, okay? So this template has a trick, which is this. You see that here within these curly braces is the name of a, here. Curly braces, name of a field, colon, formatting, okay? In this case, we have name of a field, colon, formatting, but the formatting has another field inside. This allows me to parameterize the right justification. See, this greater than sign here will do right alignment of the names, and this is going to give, this could be a constant number, but since it's a variable, it's going to give me a variable width of the column. Okay? And the way I do this is I pass as the name len, the self.maxNameLen, which although I am reading from the instance here, is actually a class attribute. So that's not a very good example of code. Sorry about that. I should have written camper here, but it does work. You know, it's just not clear. Here, this is better. Camper.template. If you're going to talk, if you're going to refer to a class attribute, use the class name. Makes it more readable. This also should say camper.maxNameLen. So what happens here is every time that I create a new camper, I update the maxNameLen when I see a name that is bigger than all the others that I've seen so far. So this class has a memory of the width of the longest name. Okay? It's not a super smart solution. If I had a bunch of these, I would have this thing growing forever. So it works for a command line script that wakes up and dies, but for a system on the web or a server-side long-running process, this would not be a good solution. It's just an example that I wanted to use to talk about, because most of the class attributes that we've seen so far were static, and this one is updated. I wanted to show that. And like I said before, if you need to update a class attribute, you need to put the name of the class. That's for sure, because if you put self here, then this would be a bug, right? Because it would create the attribute in the instance. So there's this asymmetry again. This can work by reading from self maxNameLen, but if I was writing to self maxNameLen, then it wouldn't work. It would be a bug. All right. Well, so anyway, and the budget class has a bunch of methods. But what I want to talk about some details. I don't want to describe the whole text of the class, but what I want to talk about is the fact that this class here has an attribute that I called _campers. All right? And so this is a convention. Python doesn't have a way of declaring something private explicitly, but many Python programmers, this is something where if you ask around at PyCon, you're going to hear people with a lot of people with one opinion, and a lot of people have another opinion. The two opinions are, oh, private fields, I just use this _, which is a convention. It's just a convention. Anybody can write to this easily. Okay? The other alternative would be to write 2 underscores. And I have an example here in in the number 4 classes notebook that talks about that. So I have a class here called black box. Let's say that the black box is something that I use to, is a physical black box that I have that I store things in it. And anyway, so it has a top and a bottom. But notice that the top is the top attribute is written with 1 underscore, and the bottom is written with 2 underscores, right? And I put, so when I create this black box, I put gold in the top and diamonds in the bottom, okay? So if I do that, I can read the top easily, right? But if I ask whether there is a bottom attribute, it says false. If I ask about the top, it says true. Actually, so this function asks, does this object have that attribute? And it says true, but it says it doesn't have a bottom, even though it's written right here. But the thing is, with 2 underscores, you are telling Python, please hide this a little bit. And the way Python hides it is by prepending the name of the class with 1 underscore in front of the name of the attribute that is preceded by 2 underscores. So this is the best we can do in terms of private attributes, okay, in Python. However, a lot of people that are super smart and that I respect a lot hate this. They think this is just too private. My main reason for not using this on a daily basis is that I think it's ugly. And I think this 1 underscore is good enough, you know. But anyway, this is, so it's easy to bypass, right? So if I write this code here, I am reading the diamonds from the bottom, but I'm doing it on purpose, right? It's not an accident. I am going a little bit out of my way to read that, right? So the main idea of that is like a safety switch like this, or a safety cover in a switch, you know? This won't prevent a terrorist from hitting the switch, right? But it does prevent somebody from doing it by accident. That's the idea of the private. And by the way, it's the same thing in Java, you know, because through reflection, the reflection API in Java also lets you go and access the private fields, except it's more code. But it's the same situation in Java in terms of, it's not really a security feature, it's a safety feature, okay? So like I said, Pythonists are divided about that. And another thing that is related is some people advocate that you just use public attributes everywhere, no underscores at all. And if one day you need to protect it, then you turn it into a property. Is another option. And another thing that is, I think, a good point is that excessive use of getters and setters is actually weak encapsulation, right? Because if you have a lot of getters and setters, that means you're exposing the state without any controls, right? So that's about, so the camping budget allowed us to see some techniques about using a mutable or a class attribute that we updated. We also saw the interaction between 2 classes where the API, the end user API of this, it only presents the budget because the camper is created. It's used internally here So the end user doesn't need to know that there is a camper class, only the budget class. In fact, I could write this with an underscore in front, just to tell people that the camper is part of my implementation, but it's just a convention. However, in this case, it's not just a convention, because there's a difference because this is an attribute of the module, right? The class is an attribute of the module, right? The top level. If I import star from a module, Python does not import things that start with one underscore by default. So it becomes a little bit more private, but not really. That's just a detail. Anyway, I don't do that often. Okay. And now let's go to the fifth thing. Okay. Now finally let's talk about inheritance. And because of all the discussions about inheritance, I decided to pick an example from the book of the people who invented the term object-oriented, right? So this specification says financial history, class protocol. The word protocol is used in Smalltalk, but also in Python and some other languages as a synonym of an interface, okay? So this is the description of the interface of the class. It says the methods and it explains what each method does. This is from that book. This example is a running example in that book, so this text is actually in the first page of the book. And this is a UML diagram. And in this diagram, you see financial history is the one that is here, although here it's with Python syntax, not Smalltalk syntax, the names. And this arrow here with the open triangle is inheritance, right? So contrast this with this. This is composition, right? So it says that a budget has one or more campers in it, and this is inheritance. This inherits from that, okay? And so let's take a look at the example that is in the repository. So financial history is, let's take a look at the README, because the README has some doc tests. So this is like a high-level description of the API, but this is the demonstration is more interesting. So financial history is a class where it would be like a super simple implementation of a bank account. So you start the financial history with a certain amount, and then when you display it, it shows the balance. The wrapper shows the balance. And I spend it, and I see that the value is gone from the balance. Oh, this is actually, okay, we can't see that this is a decimal, but we're going to see soon. Anyway, I'm formatting the number, the balance. And now I can receive, so I say receive the amount from that source. So I won $1,001 at Molly's game, and I found $10 on the street. So this is my balance, and I'm spending money. And now, I have methods that allow me to filter, so I can ask, what's the amount spent for meal? And it says this. So this value is a decimal. See? This is what I was formatting over there when I did the balance. Anyway, so this is a decimal. And I'm going to talk about why it is a decimal. and I can check the amount spent for travel is 0. I didn't travel. All right. So let's take a look at the implementation. Okay, so the interesting thing about this class is, besides being a classic example from the history of object-oriented programming, is that in Python I decided to use decimals to deal with money, which is a best practice. Because I don't know if you've seen this, but I'm going to show one problem with. So I have x equals 1.1, okay? Good enough. Now, let's print x. All right. Now let's print x with lots of decimal cases. Oops. Sorry. Oops. So even a simple number like 1.1 as a float has an imprecision, right? So the problem is every machine, this is not a Python bug. If we call this a bug, it's a bug that exists in every machine that implements the IEEE 742 standard for floating point arithmetic. This standard converts decimal numbers into a binary representation where 1/10 is a repeating bit, or not a repeating decimal, but a repeating bit, or a repeating bit pattern. And you know, just like when you divide 1 by 3, you get a repeating decimal. When you divide 1 by 10 and represent that as a floating point number, you get a repeating bit. So there is no way to show these things with precision, or not to show, but to represent them in precision with the way the machine architectures are implemented today. So the solution is to use float, decimal, the decimal class, which is what I used here. Okay, so that's why, for instance, where is the, so decimal is like this, for instance, if I do it's kind of tricky, but let me show you. So if I do so fraction is another Python class. So I can do 10th equals fraction 1/10. So yeah, the issue here, let me show, is if I try to build a decimal from this x, I will have the same problem. Take a look. See? Because x is a float, so it is hiding this error. And but if I do like this, I create a fraction, for example, then I don't have the problem. Oops. I thought I could do that. Oh. That's weird. Well, okay. So here's the thing. I can do this. Sorry about the detour into the fraction. But if I convert the float into a string, then Python does a trick in order to not scare people when you do print, which is, although internally 1.1 is really this weird number here, when you, the dunder stir of floats has an algorithm that goes like this. Okay, so this is the float that we have. In the machine, this is its value. But are there other floats with less digits that result in the same periodic repetition? If yes, then it's going to pick the shortest string that does that. Does that make sense? So this is something that was introduced, I think, in Python 3.3. And now, if you don't care about revealing this imprecision, you can always create decimals by converting the float into a string, and then you have a decimal that looks like what you wanted. Okay? So anyway, this is the trick that I'm using. Now, when I created this example, I want to tell you that my first idea was, okay, I wish the decimal class did that for me. When I passed a float, that it converted to string and then built the decimal from the string to lose the error of the float. But then I actually talked about that on Twitter with some people. Even Guido answered my questions about that. And they said, no. The decimal must be utterly precise. So if you're constructing a decimal from a float which is imprecise, the decimal will be as imprecise. Will be precisely as imprecise as the float that you gave it. All right? Okay, this is how they want it. And I said, okay, I'm going to create a class called new decimal that inherits from decimal and that looks at the argument to the constructor and converts it to a string before, okay? So that was my first idea. And this is another example of why often inheritance gives you more trouble than it's worth. My first idea was, okay, I'm going to create a more perfect decimal, the new decimal, okay, as a subclass. The problem is, then I had an init that was like this function here, okay? The init would take the argument, the value, and see if it's a float, then it would use the wrapper to convert into a string, and then we would build, you know? If I gave it an integer or or a string, it wouldn't do anything with it, but if it was a float, it would convert with this. This was the logic that was inside my dunder init. However, it didn't work. My subclass of decimal with a dunder init with this logic didn't work. You know why? Because the decimal is immutable. So when I get the self that was constructed by the Python machinery, the value is already set. I cannot override that value. So that meant that I had to go under or deeper and implement another method that we seldom use on a daily basis, which is the dunder new method. Dunder new in Python is the actual constructor, the method that builds an object and returns it. Dunder init doesn't return anything. It just initializes attributes, right? So, but then when I created dunder new, it behaved in a weird way because I needed to use the decimal to construct the class, the instance. So I had my own class, but when I instantiated it, the instances were all decimals and not new decimals. which was kind of weird. So I said, you know what? I don't need inheritance. What I need is a function. Okay? So this is an advice. Think hard if a function isn't better than the class that you're thinking about. Maybe it's all you need, a function. Okay? So this is what the new function, the new decimal function does. So everywhere in this code here, I'm using new decimal to start the balance. The incomes and expenses are default dicts. Default dicts is a special subclass of dicts in Python that you pass, when you build a default dict, you give it a function or a class that is going to be used to create instances when no such instance exists. What does that mean, for instance? The expenses is a dictionary. But if there is no travel expenses and I ask for travel expenses, this will immediately create a decimal and return that to me. This is what the default dict does. So it's a dict that when what you're looking for doesn't exist, it will create at once that thing and return it to you. Return this default value. That's why it's called the default dict. Okay, so this is a default dict that is going to be, by default, returning 0 decimals. The initial balance is also a decimal because of my new decimal function. So everything here is in decimals. So this is just an example of doing proper Python coding using money, which is using decimal instead of floats to avoid those accumulation errors that happen when people insist on spending fractions of 10, like 0.1. Anyway, yeah, so the rest of the class is not very interesting. Another thing that I did here is I decided to have the balance as a property. So this decorator here means that I can read the balance as if it was a data attribute. And you can see that in the example. That's in the history. See in the here, I'm not invoking the balance as a method. There's no parentheses here. I'm just reading it. And the way to do that is by declaring something a property. There's more to properties than this, but I am afraid I don't have time to talk about that. Oh, sorry, this is another example. So this becomes a read-only property. It's basically a method that's a getter, but because it's decorated with a property, I invoke it, I access it as if it was a data attribute and not a method. I don't use the parentheses. Okay? Another thing that is interesting to talk about is that although it is a little bit of work using decimal, it's less work than it would be in some other languages that don't have operator overloading. Python has operator overloading, so that means that this works. I don't have to call a method on the decimal. I just use an operator. Right? In Go, for instance, there's no operator overloading. In Java, there's no operator overloading. So you wouldn't be able to use this short notation to add and subtract. You would have to have a method like dot subtract, dot add, and so on. Anyway, so I wanted to show an example that is a classic example, but I also implemented it using decimals, which makes it a little bit more interesting. And this is also an example of subclassing, because in the book, they give an example which is the deductible history. So the idea is, in this class, you can do expenses that are partially or totally deductible. So in this example here, I'm saying that I'm spending 600 for a course, but the course I can deduct $150 of that course, of that expense, right? I can also make a donation, and in this case, there's another method called spend deductible, that is to deduct the full amount, okay? And then I can see what are the total deductions, 400, right? Because I spent, this course cost 600, but I deducted 150, and this course, or this donation was 250. No. Yeah, donation 250. So far my deductions are 400. So this is how it works. It has some different methods that allow you to expand with deductions, and this is the code. The code is interesting because it shows an example of inheritance, which requires the use of the super function. Okay? So the thing is, when you create a subclass, you need sometimes to invoke a method of the superclass to do stuff. For instance, my dunder init. So a deductible history is basically a financial history with this extra attribute, that is the deductions, which is just a decimal number. And this spend method that now has an extra optional argument, and the spend deductible, which is a new method, and the deductions, which is a new property. Okay? So in order to leverage the machinery of financial history, I have to be explicit about this. For instance, in the initializer, I invoke the initializer of the superclass. And by the way, this is different from the way it works in Java, okay? In Java, the constructor automatically invokes the constructor of the superclass. In Python, you have to be explicit about that. And there's two ways of being explicit about that. I could write here financial history dot init, but then I'm calling the method on the class, and I would have to pass self as an explicit argument, which is ugly. And also, Python supports multiple inheritance. It doesn't mean it's a good idea, but it does support it. And it can be used, if used very judiciously, can be useful. But not like the example that I used to have, for instance. I was so ashamed when I found that. So I had remember I said I had animals? So there was mammals and dogs, and there's several kinds of dogs, like, I don't know, Labrador. And then there was the Saint Bernard. You know the Saint Bernard? That legend says in Switzerland they use Saint Bernard dogs patrolling the roads, and they have like a little vat of cognac. So my Saint Bernard, I swear to God, inherited from dog and vat. That's just stupid, okay? What it should be is a subclass of dog, the Saint Bernard, that has a composition that includes this component, which is a vat. Okay? This is what it should be. Not an example of multiple inheritance. But anyway, I wanted to show it. I don't want to show it anymore. Multiple inheritance most of the time is bad. But anyway, you never know, right? Maybe you don't like multiple inheritance, somebody else in your team, somebody in the future, something happens in the hierarchy that you don't control. Maybe it's a third-party library that you're subclassing from, and you don't control that code. In order for your methods to cooperate correctly with a hierarchy that has multiple inheritance, you have to use super, okay? This is what super does. So the super function is a magical function that returns a proxy that by default does what it needs to do in order for your dunder init to resolve up in the hierarchy. So what I'm doing here is my initializer is delegating the initialization up the chain of inheritance. And by using super, this is going to work predictably as predictably as possible in a multiple inheritance situation. Okay. On the other hand, if I hard-coded the name of the class here, then maybe I could have problems if it turned out that the hierarchy became a multiple inheritance hierarchy later. So the syntax improved in Python 3 is still ugly, in my opinion. Calling this function like this, it returns this proxy object that then you invoke methods on it. But in Python 2, it was worse because you had to pass 2 parameters here. And now Python is smart enough to introspect the frame where this is happening in the code and getting that information, the defaults for you. Okay. So the dunder init delegates to the hierarchy and then initializes the deductions, which is this new class, this new instance attribute of my deductible history class. The spend also uses the same mechanism. The spend calls super spend, so it uses the mechanics of the spend in the superclass, and then if there was a value deducting, it adds to the deductions. Okay? So this is an example of a method that is not the initializer, but just any other regular method, delegating some of its functionality to the superclass. And the last example here is an example of one method of the instance delegating to another method of the same instance. See, the spend deductible is implemented by calling spend, repeating the amount here, right? Because the idea of the spend deductible is that it records the expense with full deduction. So it just repeats the amount and uses that one. So what I want you to notice here is the use of super and self in this delegation. So delegation is a fancy word that object-oriented programmers use to say when one object tells the other object to do something, right? And in this example here, this is called a self-delegation. The object is telling itself to do something, right? And this is a super delegation. Anyway, so it's an example of inheritance. However, although it's, like I said, it's a classic example from a very important book in the history of object-oriented programming, nowadays is not considered an excellent example. Many authors don't recommend anymore to do inheritance of concrete classes. Okay, so what we have here is financial history is a concrete class. I can create instances of it. And the deductible history is another concrete class. This creates complications that, because both classes have inner states, so they can step on each other's toes. You may forget to invoke super. It would be a good good exercise to rewrite this just to feel the difference using composition, you know? So deductible history is a class that has a financial history inside it. And then you wouldn't need to use super anywhere. You wouldn't need to do self-delegation. You would write a little bit more code, but it would be clearer. And it would be more flexible. The problem one of the problems with inheritance of concrete classes is that it's a very tight coupling between the subclass and the superclass. And that's something that you want to avoid to make systems easier to evolve, this kind of tight coupling, okay? But I needed to show you this because I needed to show examples of super. When you notice, when you are inheriting from an abstract class, you don't have these problems because there's no implementation for you to leverage. You need to implement everything mostly, right? This happens really when the need of super appears when you're doing inheritance from one concrete class to another. Okay, so this was, okay, this is the inheritance, the classic example, we've seen that. Okay, so this is a series of examples that talk about different ways of doing inheritance, right? So each of them will lead you to a part in the examples over there. So the bingo is a very simple class that emulates a bingo cage. So the idea is you fill it with balls, this cage, and then you call pop, and it gives out a random ball, right? So that's the mechanics of the bingo cage. You put a sequence or a collection of items in it, and each time you call pop, it will give you one of those items picked at random. There's also a len, so that you can ask how many items are in the cage, which also allows you, because the bool built-in function of Python uses as a fallback the len to determine whether something is true or false. So you can do this code. While cage, print next item, else no more items available. So this will be a loop that will repeat until the cage is exhausted. Okay? Anyway, the implementation of this is super simple, but oh, where is it? Yeah, this is it. I use that trick that I told you about before, which is making a list, because otherwise, every time I do pop, I'm going to be, throwing away something that belongs to my user. So this is a very simple implementation. Now, the fun part of this is with the other examples here. The other examples here, which are in the tombola directory. So tombola is an Italian or Portuguese word which is a synonym of bingo. And this directory here, tombola, has several implementations of different bingo machines, and it has a single test suite that works for all of them to prove that they all behave the same, even though the implementations are very different. And this tombola.py is the ABC. So this is how you declare an interface in Python. If you want to formalize an interface in Python, what you do is you import ABC, and in the ABC package there is an ABC, uppercase ABC class, which when you inherit from it, it means that your class is an abstract class. And in an abstract class, you can use these decorators, ABC abstract method, to say that you expect the subclasses to implement that. Okay? So I'm saying here that a tombola machine has to have a load, a pick, and a loaded, and an inspect module method. The interesting thing here is that load and pick are abstract methods, so they only have a docstring, there's no body. But the loaded and the inspect are concrete methods. So this is something that Python allows you to do. An abstract class can have concrete methods as long as they depend only on the abstract methods. Because then the subclasses will implement the abstract methods, and the concrete methods from the abstract class will be able to leverage them. So, for instance, the loaded, which should tell you whether there is at least one item or not, will call inspect and convert the result into a Boolean. The inspect, this is very strange, okay? But my idea was to illustrate a concrete method in an abstract class. So the inspect returns a sorted tuple with the items currently inside. But I cannot look at the implementation, right? I don't know what the implementation is. This is an abstract class. What I know for sure is that the implementation will have a pick method, right? And the pick method will raise lookup error when the instance is empty. This is written in the documentation. It's the contract. It's in English, not in Python, okay? Anyway, so my inspect relies on that. So what it does is it creates a list called items and then goes into this loop where it's calling pick and appending to the list until it gets a lookup error, then it breaks. And now it has emptied the machine. And now it loads it again with the items and returns the tuple of the items. Okay? So the way that inspect works, since it's limited to rely on the abstract method, is by invoking pick until it exhausts everything, and then puts it, and then it loads back the things in the machine, right? So that's how it works. So this is an abstract class, and here there are other examples that I use it, where I use it. Okay, so the lotto, for instance, is a lottery blower inherits from tombola. I initialize load and pick, and I have a better implementation of loaded and inspect. Okay, because I know the implementation, so I can override these methods with a better implementation. But you can also have something like the drum implementation, which just implements load and pick, and it doesn't have the inspect and so on, but it will inherit from the tombola. Anyway, all of these examples, if you look at them later, you will see that they have very different implementations, but they work the same. But one interesting example, I think the most interesting example is this one here, tombo list. So tombo list is interesting because it let me hide that line for a moment. It inherits from lists, okay? Not a very good idea. All the others use lists inside with composition, okay? But I wanted to show that it's also possible to create a device like that inherits from lists. So it uses self-pop because it inherits the pop method from lists, and so on. But the interesting thing is, okay, so if I inherit it from list, how do I tell people that this is actually a tombola? And the way to do it is, because tombola is an abstract class, I can use it. The abstract classes in Python have a function called .register, which when you use as a decorator, registers this list as a subclass of that class, even though it doesn't inherit from it. This is what is called a virtual subclass. Okay? So a virtual subclass is a class that doesn't really inherit from the other one, but you declare that it works like that one, that it fulfills that interface. Okay? Does that make sense, people? Yeah? So this is an option that you have, and you can even do that with third-party code, because there's this other syntax here. You know, if I imported something from from somebody else's module, and I want to say, okay, this thing that somebody else implemented actually implemented this interface that I need to make, and I need to make this fact explicit, so I can call my abc.register, the other person's class, and it's what I'm doing here is I'm telling Python, trust me, this thing works like that thing. It works as if it was a subclass of that thing. Okay? But now, when I do that, there's no inheritance involved, so I really need to implement everything. Even the concrete methods that the other classes are inheriting. Okay, so this set of examples have to do with inheriting from an ABC. So this is what I was showing, variations on a bingo machine, different examples that do that implement the same interface via different means. Okay. All right. So what are the takeaways of this section? The takeaways are, okay. So here's the thing. I was kind of saying that inheritance has a bad reputation. But in fact, one of the things I found a quote by Alan Kay when I was writing my book, but I forgot to put it here. But one of the things that Alan Kay says is that he thinks inheritance was a mistake because it does too many things at once, right? And the key, and there's a book that I'm going to show you in the next section. Called Introduction to Object-Oriented Programming by Tim Budd. I have a picture of it in the next section. So in that book, the author actually lists 10 reasons why you would inherit, or why people inherit stuff. One of the reasons is classification, you know, like I was saying before, like hierarchies that look like taxonomies. This is considered wrong in most situations these days. So the author lists 10 reasons for why people inherit stuff, or why people subclass. But the two main reasons that many authors talk about are interface inheritance and implementation inheritance. So the idea is, are you inheriting because you want to say that this fulfills that interface, or are you inheriting because you want to leverage the implementation of the other thing and do your own stuff? Java has this distinction very clear, right? When you say extends or implements, right? So extends means implementation inheritance, and implements means interface inheritance, right? However, C++ and Python don't have this distinction very clear, and a lot of times when you inherit, you're inheriting. And here's the thing, when you're doing implementation inheritance, even though you're maybe just interested in the implementation, you're also inheriting the interface, right? And maybe that's not what you want, but that is what you're gonna get. So a classic example that people talk about is where squares, a square class should inherit from rectangle or vice versa. And one way to think about it is that the square is simpler than the rectangle. So if I'm thinking about implementation, I don't want my millions of squares to have the overhead of rectangles when they are simpler. They have only one width attribute, right? But on the other hand, if you can say that, okay, but all squares are rectangles. But if I do that, that also means that maybe there are some methods in rectangle that I'm inheriting and that I shouldn't. For instance, maybe I have a stretch method that doubles the width without increasing the height of the rectangle, and that would not make sense in the square. But if I inherit, I will inherit that too. So what do I do with it? Oh, okay, so you can implement it and raise an exception. You cannot stretch the ugly, right? But it's a complicated situation, but you have to be, this is an important thing. This is a hint. I don't, if this is new to you guys or to some of you, I put it here because I think it's something that you need to pay attention and go after and understand. But it's important to understand the difference between interface inheritance and implementation inheritance, because the bad things that I said about inheritance are mostly about implementation inheritance. Interface inheritance is not a big problem. So Python actually has, for instance, a huge so this here doesn't look like a hierarchy, but it is, because you can see that it says here this inherits from that and so on. So this is a diagram of abstract classes that the Python library brings. So for instance, you can see that a sequence inherits from revertible and collection collection inherits from sized, iterable, and container. This is actually examples also of multiple inheritance. But multiple inheritance is usually not a problem when you're doing when you're doing interface inheritance. And in fact, Java allows it, right? You can implement lots of interfaces, but you can only extend one implementation. So you and then you have a mutable sequence which inherits from sequence. See? So this is a tree of collections in Python that is useful to study to understand what is available and how the collections in Python are organized. Anyway, the point is that, and like I said, for instance, when I mentioned Julia before, the Julia language allows interface inheritance arbitrarily deep, but it doesn't allow implementation inheritance. You cannot subclass concrete classes in Julia. Yeah, I already said that. I avoid inheriting from concrete classes. Oh, here's the thing. Built-ins. I put one example here where I implemented Tombow list as a subclass of list. Okay? This example works because the things that I do with the list are not complicated, but there is a problem that the built-in objects in Python which are written in C, they don't always call, when you subclass one of those, they don't always call your methods as they should. In terms of the C++ world, is what they call the implementations in C of these objects have non-virtual methods, which are hard-coded to do something. So one example of this is, for instance, let's say I want to create a list that only allows numbers in the list. Okay? So what I'm going to do is I'm going to override the method append to make sure that whatever is being appended is a number. And I also going to override the dunder set item, which is the one that when I assign to a position using square brackets, it's also going to do that. But then there's a method called extend, right? Which you call to append a bunch of items at once. And if you think you can rely on the C implementation to call your own append repeatedly in the extend implementation, it's not going to do that, right? So this is a tricky thing, and that's why in the collections page that I just was showing to you, there is a user list, a user string, and a user dict class. These are the ones that you should subclass if you want to have your own custom list, your own custom dict, or your own custom string, okay? And it's interesting if you take a look at the code of these classes, they are done with composition. So the user dict actually has a real dict inside of it, but it implements all the methods to do delegation, and so it makes sure that everything goes through those methods that are written in Python. And that advice from the Gang of Four that I already mentioned, favor object composition over class inheritance. And we got a sign that we have 5 minutes, and that's good because now we can go to the big ideas. All right, so big ideas. So I had a lot of fun going back to the origins of these ideas to think about an introduction to this subject. And one of the things that I found was an email from Alan Kay, who was the leader of the project that created Smalltalk. So this guy, Stefan Ram, asked him, "What does object-oriented programming mean to you?" And he says, OOP to me means only messaging, local retention, and protection, and hiding of state process, and extreme late binding of all things. It can be done in Smalltalk and Lisp. There are possibly other systems in which this is possible, but I'm not aware of them. So it's interesting because inheritance is not here. And messaging is basically method calls. And there's and local retention and protection and hiding of state process is encapsulation, right? Extreme late binding is doing that thing that I just told you that the Python built-ins don't do correctly, which is to respect the inheritance hierarchy when one method delegates to the other and go to the proper level in the inheritance hierarchy to resolve that. This is what is called late binding. The problem with the implementation of lists and dict and string in Python is that there's early binding, so some of the methods in there are hard-coded to delegate to others in C. And another thing that I found is a message by, recently there was an interview, very interesting interview with Joe Armstrong, the inventor of Erlang, died last week. And Erlang is a language that is totally based, is not an object-oriented language, but it's totally based on the idea of multiple processes exchanging messages. So although it's a functional programming language, it goes closer to the core idea of what Alan Kay now defines as object-oriented than Python and Java and so on. And so there was an interview that was great. Joe Armstrong interviewed Alan Kay. I really recommend that you look it up on YouTube. And the last thing that I wanted to share with you that was a result of this research that I was doing, I already have a bunch. I have like I don't know, 2 yards of object-oriented programming books in my office that I bought over the last 30 years. But this one is a new one for me. It's not new. It's from 2003, but it's super interesting. I don't know why I never stumbled on it. So it's called An Introduction to Object-Oriented Programming by this Professor Timothy Budd, who teaches at, I think, Oregon State. And what is great about this book is it's the only book that covers general topics in object-oriented programming with a very good depth, and that does it with several languages. It's not focused on a single language. The book actually has examples in all of these languages. So it's really interesting to really understand object-oriented programming, the paradigm in general, as opposed to particulars of this or that implementation. And one of the great things, I want to finish with this, one of the great things about that book is that I found a super elegant solution to the 8 queens problem, which is a classic problem that Dijkstra created to demonstrate backtracking. Or he didn't create, the problem existed since the 19th century. The idea of how do you place 8 queens on a chessboard so that none of them attacks each other. And that's super hard to do, actually. If you want to try it, I recommend starting with 4. There's no solution for 2 or 3. With 4, there's basically one solution, and you can find it in a few minutes. With 8, I don't know. If you're serving time, that may be a good pastime, because it's... anyway, but what is beautiful about this solution is because when I thought about it, okay, so object-oriented 8 queens, how would I think about that? And the way I would do is, okay, so I'm going to have objects that represent the queens, and then there's an object called the player that is going to move the queens. And then I implement Dijkstra's algorithm in the head, so to speak, of this player, right? Well, this is an anti-pattern of object-oriented programming called, you know what it's called? The God class. Is when all the logic of a system resides in a class that just moves the others as pawns. So the nice solution of this, the nice idea of this example, and I wanted to show you this because this is an example that for me really summarizes what object-oriented is all about, is that you have this queen class, okay? There's a problem with so the queens, the idea is that the queens communicate, right? So each queen will collaborate with a neighbor. And this will work recursively. So when the last queen found a solution, that means that everybody else found solutions as well. The first piece of the solution, the first queen in one of the implementations here has a lot of ifs, because, oh no, if I am on the edge of the, I don't have, if my neighbor is none or whatever, this kind of thing. But this solution here has a special piece called the guard. And if you look at the API of the queen, it has can attack, advance, find solution, locate. The guard has 3 of those methods implemented, and for advance, it always returns false, meaning I can't advance. Can attack, false, meaning I can't attack. And locate, meaning this would be to return a list of the positions of everybody else. But I'm like the sentinel. So they start with an empty list. And the queens, so for instance, when a queen the queens are positioned each in a row, and they move and until they find a place where they cannot be attacked. If they can't find a place where they cannot be attacked, then they will ask the neighbor to move again. So this is basically how it works. And the main program is this. So it creates a guard, this is the figure, and then for each row of the board, it creates a queen, passing it the number of columns so it knows how to move, the number of the queen, and the figure, which initially is the guard, but in the next iteration is going to be another queen. And then so it creates a queen and asks the queen to find a solution. If any of them at this stage say not found, that means there's no solution. The first one is easy, right? The first one, anywhere that it rests, it's okay. The second one, the first position will be attacked by the first one. Second position also. Third position, no, it's fine. Okay, so it rests there. And the third one, and so on. So the great thing about this as an example is that it goes back to the idea of another of the visions of Alan Kay, was that an object-oriented system is an autonomous system, is a system of autonomous objects, sort of like cells in the body. Each cell goes about doing its own thing, but they also collaborate. And this solution of the problem is difficult to understand the algorithm, but it's elegant because it's very object-oriented in this sense that the queens collaborate to find the solution, and there is no God class. Anyway, so this was a great finding when I was doing research for this workshop to discover this book. I learned a lot reading it, and this is basically it. And if you can please fill the survey, we will be very happy. And I'll be around the next days. I also have cards here if you want to contact me. I do have, there was another lab that we didn't have time to do. If you want to do the lab as homework, you can write to me. There's my email here. And I will help you do your homework if you want. And that's it. Thank you very much, folks.